Right, the graph shows the velocity v meters per second of a rocket at time t. Find an estimation for the rate of change of the velocity of the rocket at time t. Time to t equals 2. Right, I've already drawn the tangent on there because it kept disappearing. So, to work out the rate of change, we basically need the gradient of this line. So it goes up to 18. So it's the change in the height. So it's 18 by change in across, and I've gone across about 1.6. So it's 18 high, 1.6 across. So 18 divided by 1.6 gives you an answer of 11.25. Now, if you haven't got that answer, don't worry, because there is a range. It gives you a range of 9 to 14. So there is quite a range to work with there. Right, part B. Find an estimate for the distance travelled by the rocket in the first 4 seconds. Gives you a bit of a clue there. Use 4 strips of equal width. So you basically, it's trapezium rule. So you basically divide it into 4 trapeziums. Trapezii even. Okay. So first one here is a half of the parallel sides added together. Well, that's 0 and 1. And then you'd have to multiply it by 1. So let's not worry about multiplying it by 1. Next one goes up to, well, again, it's a half. First one is 1 plus, I think that goes up to 9. You are allowed plus or minus 1 on these values. Then the next one is 9. It's the same value. And this time it is, I think that is 25. And then the final one, plus a half, which is going to be 25. Get the brackets, plus whatever that goes up to, 60, I think 62. And then it is just a case of putting it into your calculator. You end up with a half, plus 5, plus 17, plus 43.5, which gives us a total of 66 meters. Now, if you check the mark scheme, I think the mark scheme gives you 66.5. But that's purely because you can have plus or minus 1 on all of these values. So trapezium rule, 4 equal width strips, and you can work out the area.